the objective is basically to bring users to Codex, and BitTorrent seemed to be one of those options. I think there's, I have it, should have it here actually, let me describe, yeah. So bring BitTorrent users to Codex, and does it make sense? So actually, when we started to think about it, the very first thing that I did was to look into what's on the horizon, how BitTorrent is standing right now. It's because it seems to be technology in decline from one perspective. You would expect that less and less people will be using it, but surprisingly, you see that it's still active, and there are still new releases, and there are commercial products around BitTorrent, and there are some future extension plans even. So it seems that the intention is to keep BitTorrent alive and maybe even make something bigger out of it than it was. Who knows? And so it may be actually the case that they are still interesting communities and maybe lots of content attractive enough to have it on Codex. And by doing that, we hope we can bring some new users to Codex as well. And while having BitTorrent, and I will talk about it later. So if we ever integrate Codex with one of the BitTorrent clients, then the idea is that the people should very soon realize the advantages of Codex, and that Codex is giving them much more than BitTorrent, which is very single scenario oriented thing. It's just publishing content and downloading content. There's nothing more really that you can do with BitTorrent, I think. And with Codex, we just showing that flexibility and versatility of Codex is big enough to support multiple use cases, and supporting BitTorrent is just one of the use cases. And with extensions that comes as native things in Codex, like support from marketplace, storage providers, we can actually provide, for instance, warranties for the content which BitTorrent doesn't provide. And BitTorrent is purely opportunistic in a way, like altruistic. You can only get best effort.
There's never whoever has the most interesting content, usually that's the content that's well seeded, right? Like latest movies, latest music that's popular. Like I remember when I was like a teenager, like I don't know if you've had this similar experiences, Marcin, where you're part of like a private tracker group, and there's a specific category of content that they congregate around, whether it's books or music. Usually they have a bounty board, right, for really, really obscure, hard to find FLACs of vinyls. And there are bounty amounts that are sometimes denominated in fiat, right? I can't imagine why we couldn't do, a crypto version of that. I'm pretty sure that already exists, right? So we'd basically just have a better way of guaranteeing persistence for the data versus just banking on popularity and banking on ultra people seeding the content forever, which it's not the case.
Yeah, definitely. So yeah, I think so. That's why we in a way hope that if people see what they can achieve with Codex by first seeing that it performs at least equally well, let's say, as BitTorrent, and that we have enough content on Codex, that it's possible that we will bring more users to Codex. So it's we don't know in the end, but it's I think worth exploring that path. And it's important to say at the very beginning, maybe of our today's meeting, that if it doesn't work, it doesn't work. We try to go as far as possible, and on the way of getting there is lots of things that we want to achieve while doing this. So experimenting with BitTorrent and how to bring it and integrate with Codex is not only to bring users to Codex, but it's also to learn from experiences of BitTorrent and its ecosystem, because they are years long out there, and they had to fix number of problems, solve challenges that we will just still experience with Codex, most probably. So currently, I remember Giuliano did, for instance, nice performance analysis for BitTorrent comparing with to Codex. From this, we get some learnings about where we need to improve. We look at some solutions at the protocol level that BitTorrent did and see how we can apply them in Codex. Yeah, I think that's the most important thing. But also in a way, our work on BitTorrent is paving the way to maybe bigger things that we want to bring to Codex in the future, like also supporting small content files and dictionaries, and even mutability of the data, which we know that Codex at the moment is immutable blob store in a way, and want to see what we can do more about it. So these are the biggest why, and maybe worth to mention that while getting there, well, we wanted to see how far we can go without really like without introducing too deep changes to Codex protocol on its own. So we tried to do it in non-obtrusive way, like put BitTorrent layer on top of what Codex exchange protocol can already do, and that's additional technical difficulty, right? So
I did put a link in the StreamYard just as a temporary overlay, because you referred to the benchmarks that Juliana was doing, and just so in case people are interested, they can follow that link.
That's great.
And then we can put a link in the description of the video in post-production, in case people are interested in seeing the benchmarks and then the code.
Yeah, it's very nice. So let me for a moment jump here. So we have why. So I usually like to show in how we achieve what we achieve, because it's like working on BitTorrent extensions, and also it's opportunity to also understand differences and subtle changes between BitTorrent protocol and Codex. So this discussion is also will be in a way quite technical still. I would like to maybe start with a bit recapping on how BitTorrent deals with the content, so that we can smoothly go to how we integrate BitTorrent extension into Codex. So recap a bit of BitTorrent, how does it perform? So normally, yeah, in BitTorrent you have it in dictionary of a file. In our discussion, I would probably prefer to stick to file only for simplicity. It's maybe good to mention we have BitTorrent version 1 and BitTorrent version 2, of course, also. And there are a number of changes in version 2, which will result in some ways better performance here and there, but most importantly, faster validation of the contents and so on. In this discussion, I'm focusing on version 1. The reason for that is that from what we see, it seems that still most of the content out there is version 1 actually, and supporting version 2 on Codex will be in a way even easier than supporting version 1. That's why I'm focusing on version 1 here. So we have file. Let's say we want to the owner of the file want to seed, upload the file to the network. The network in which would immediately trigger something like a swarm. So the seeding, the owner of the file, while seeding, you create a torrent file, which is like a metadata file that describes the content that you want to publish. And this torrent file is not really human readable thing. If you open torrent file, you will see something that I'm presenting on the screen on the right of the torrent icon. It's B-encoded content. So pieces of it are text indeed, and you can recognize elements of it, but it's a machine readable format, and it's intended to be used like this. Below, I show the equivalent of that B-encoded content. How does it really look like if you show it as a JSON? So you see a couple of important properties. Unknowns thing is important to mention because you, Jessie, just a moment ago mentioned about trackers. And originally BitTorrent use trackers as orchestrators for swarms, which is the group of peers interested in a given content. We'll show in a moment how BitTorrent actually went from using trackers to using DHTs and why it's important for us. But you still see in lots of torrent files, you will find unknowns, which is the URL of the tracker, and tracker will orchestrate the download of the content between peers, knowing which peers have what and which peers are in the swarm and so on. And then we have info dictionary, a very important piece of information in torrent file, which includes length of the content. In this case, this is a single file, so it's just a length attribute. When you have multiple files or dictionary, you will have a files attribute with paths and names of the content under each path. In our case, we only have one file again, so it's only length. The name of the content to be shown at least while downloading this name in BitTorrent is not obligatory, it's optional. Piece length, that's something maybe will become cleaner in a moment, but shortly in BitTorrent, the data is logically distributed in pieces, and every piece has a length. In this case, it's 64 kilobytes. Normally in BitTorrent, the most commonly used piece length is, I think, 256 kilobytes, but when the content becomes bigger, the piece length can be even bigger. And then we have a pieces attribute in info file, which is a list of hashes of every piece. In our case, we have very small single file, 40 kilobytes actually, in this example, and we have just one piece, therefore, and only one hash in example. This info dictionary can be then also be encoded, so it also again becomes, it's actually extracted from the torrent. Yeah, if you could select in the torrent be encoded file just the part which is covering the info dictionary, and then if you hash this be encoded info dictionary, you will get something called an info hash. And in BitTorrent version 1, this is SHA-1. In version 2, it's SHA-2 256. That was also breakable change between version 1 and version 2. And this info hash is actual content identifier. If you think of content addressable content, then yeah, you put the content on the network, and this is actually the content identifier by which you will be referring to the content. Yeah, here's just what I said. We have file, we have pieces. Pieces in BitTorrent are, well, actually in version 1, there is some freedom in sizes of pieces, but they make it more concrete and more constrained in version 2. So I'm sticking a little bit to the rules that already hold in version 2. They should be power of 2 and bigger than 16 kilobyte. And 16 kilobyte is the size of the block in BitTorrent. In comparison, in Codex, we have flexible block size. We can use different block sizes. And in BitTorrent, it's fixed to 16 kilobytes, while the piece, the logical level, is flexible. You can have pieces of different sizes for every content. So we have this. From this, we get the torrent file, manifest or metadata file, and then we have info hash to summarize that part. I have also this small picture, which yeah, it also shows a little bit more how the piece is mapped onto the block. So if we have this very small content, like 40 kilobytes, so you see you will have 3 blocks. Third block will be not complete. There's no padding. So the last block will be shorter than 16 kilobytes. And the piece will also, in this case, which is normally 64 kilobytes, it will be not the whole 64 kilobytes, but it will be only 40 kilobytes. But it will be still, logically speaking, one piece with index 0. If you have more pieces, every next piece will have another index, so 0, 1, 2, and this is how BitTorrent will address pieces when requesting them from other peers in the swarm. Okay, so we have this. And I mentioned that in BitTorrent, we had trackers before. So yeah, so when there was a swarm, there was one special peer tracker, which you could ask for peers by providing it with info hash, which designates the content, and your own peer ID, so that tracker also learns about you. And it gives you back the peers, and then peer exchange, block exchange protocol will take care for getting the content.
This is like, I remember, like, for instance, I remember like trying to find like some obscure anime. Like, this was back before the US started.
I think you are fading, Jesse.
Okay. Yeah. Oh, yeah. Can you hear me better now?
Yes, it's good now.
Okay. So yeah, I remember like for like some obscure anime I was trying to find. This was back before US started doing licensing deals with Japan for anime content. There used to be like gray area fan subgroups who would download the raw, untranslated Japanese anime, and then they would do dubs over it. Like Data Bio was one of them. And I remember when I was downloading some of the more obscure anime that wasn't seeded well, I would have to rely on adding more and more trackers to the specific torrent file, just because like the original torrent file didn't basically have enough trackers baked in.
Oh yeah, this is a nice point that you mentioned. I didn't say that. Yes, you can have multiple unknown addresses in a torrent file. There can be more trackers than one. And I will not show this like directly in the illustration. What is interesting in BitTorrent, that when they introduce version 2, they also introduce a number of extensions. So again, in our docs, you will find quite extensive sources of documentation about BitTorrent. If you want to learn BitTorrent, we'll have good links to where you can find relevant documentation. Is it from the bittorrent.org, when you can find BitTorrent extension proposals, BEP, and different numbers, but also different sources out there. And so, and looking at this, you will realize that BitTorrent also went through history. They started with BEP3, I suppose, and then go for a number of things. And at some point, they introduced extension to protocols, so you can add extensions. And when they introduced version 2, through the mechanism of extension, they could introduce other features like getting metadata from the peers. So you don't need the tracker for that. If you know the peers in the swarm already, you can get the information, your info dictionary basically, or even more sometimes. In version 2, you can even get information beyond info dictionary from the torrent file from other peers in the swarm. And the nice thing is that they made it in such a way, thanks to some extensions, that they can stream the content or download the content across different swarms. So you can have swarm of version 1, and you can join to that swarm, but you can also discover that the same content is being available in swarm version 2, and also join at the same time other swarm, and at the same time downloading blocks or pieces from different swarms, different versions of the protocol. This is quite powerful because most of the content will be available in version 1, so you can do that this way. Yeah.
Did you ever like do I remember like practically speaking, what you're...
Yeah, I think I lost you again, Jesse, I think.
Oh. There we go. Okay. Yeah, no, the practical, like in my mind... Still
not good. Still not good.
Oh no.
No. I think you have to check that cable in the end.
Okay, I'm gonna switch to the webcam mic. It's gonna be worse, but at least I can talk with you.
Yeah. Okay.
Okay.
I hear you now.
Okay, perfect. So when you're talking about the explanations of the details, all I can think of is when I was like, like I was like 12 years old or like a kid, right? And trying to get access to certain things. And some of the details, like the practical explanation of what you're talking about is that V2 is backwards compatible with V1. And what I still actually don't know is why is there so much content living on V1 versus V2?
Well, I think it's just because I think the real reason is that adoption of the version 2 of the protocol was slow. I think that's actually a reason. If you look when libraries like BitTorrent started to support version 2, I don't remember now exactly the year, but it was not that long ago. So actually, BitTorrent spec was hanging out longer than it was supported in the software, basically. And still today, even not every client, especially open source client, not every client supports all the things the same way. So sometimes some version 2 things are supported better, some not. So I think that's the real reason. And then, of course, if people were uncertain of how many clients will be supporting version 2, and then how many users will decide to switch to version 2, which will be even less than that, and then traditionally more of the content seem to be hanging around in version 1, especially that, well, okay, version 2 adds some important things at the level of how quickly, for instance, it can validate integrity of the content. Because version 1 could do it only at piece level. So you had to get the whole piece. And remember, we had the 16 kilobytes blocks, and the piece could be, let's say, even 4 mega for very large content. If you have like few giga of movie or something, then it could be that the piece length will be as big as 4 mega. So you have to get this 4 mega from the network before you know you are getting the right content. And in version 2, they can do that at the block level. So that's significant improvement over how quickly you realize you are getting garbage, basically. But otherwise, yeah, protocols are still quite similar. So I think when people don't have very sophisticated content, like single file, a big file, or maybe even dictionary, but only with few items, then version 1 is very often sufficient. And yeah, so I think, yes, there are improvements, but sometimes for the user perspective, they may be not really worth of switching, basically. They may not see immediate advantage. I think there may be occasionally improvement in download speed and things, but there are no significant changes to the block exchange protocol, to my best knowledge. Yeah.
Yeah,
so,
it looks like I'm listening to you, and I'm also reading this article, and I'm actually wrong. Apparently, the way that I guess torrents are compiled, the newer version is not backwards compatible. So like while you're
no, it's
like,
not
your
actually.
explanation. Yeah, I didn't realize that. Okay, so like you can share swarms between the torrent files, but the torrent files are fundamentally differently hashed, right?
Yes. Yeah, they not only use different hashes from SSH1 to SSH2, but when they realize, we do need to change the hashing function. So they decided at this point, they knew it will be not compatible anymore, not backward compatible. So they decided, okay, let's do some other improvements that we wanted to have, like introduction of Merkle trees to make it possible to validate content at the block level. Let's get the torrent files actually shorter and more compact, especially changing the very big files attributes which were repeating the same folder structures over and over, and they decided to make a tree-like structure to show the files and folders. So yes, they brought those changes, but indeed those two are not compatible, but again, thanks to protocol extension, you can participate in both torrents. And even they have a notion of hybrid torrents. And in hybrid torrents, you can mix attributes for both info version 1 of the protocol and info dictionary version 2. So you will have, for instance, files from version 1, but then different attributes for version 2, like piece layers and the tree. I think the tree is the attribute for version 1, I think, to represent the files. Which I would have to check. Maybe I'm wrong actually about it. But anyway, yeah, you can mix those two, and by this, the compatible clients can recognize that you are your client, that you want to take advantage of version 2, and if they support version 2, they can try to join Swarm's version 2 if they are around.
So you're right. So it's like, I'm just skimming the article. It says important changes under the hood. While new torrents are the most visible change, for outsiders, it's merely a byproduct of important changes under the hood. For example, the switch from SHA-1 to SHA-256 hashing will prevent a possible hash collision, which can be used for attacks. And Norb tells us that the risk of these attacks is mostly theoretical, but this may change over time. So changing to SHA-256 is certainly wise. An even more exciting change, according to the developer, is the use of per-file Merkle hash trees for the piece hashes. In simple terms, this means that all files in a torrent will have their own unique identifier, a hash. So a collection of 100 photos will have a unique hash for each photo. This comes with several advantages. For example, it will allow torrent clients to quickly check if they're receiving the right file. This prevents dilution attacks that can be used by outsiders to slow down torrent transfers. With the V2 hash trees, corrupt data will be immediately detected, and the peer responsible for it can be disconnected. Currently, there's more complex heuristic involved in attributing corrupt data to a peer, which means a malicious peer can do slightly more damage before being disconnected. Yeah, interesting.
Yeah, I just checked here. Indeed, the new version, the attribute that replaces the files attribute from version 1 is indeed not actually tree only, but file tree. And yeah, so that's the difference. And there's also a new attribute outside of the info dictionary called piece layers, which is maybe outside of scope right now to maybe explain fully. But this piece layers provides basically hashes from them, like in the middle of the Merkle tree. So every file is kind of a separate. It has its own root, its own Merkle tree, basically. So actually, the BitTorrent content can be seen like a forest of Merkle hashes. Actually, I do have a very quick visualization of this. If I switch to here, and I should be able to show you a good example. It's not going over the details, and I want to show you something. Like this is a nice example. We have a torrent file. This is version 2 now with file tree. There are 3 files, and you see every file has this piece root, which is what you mentioned. This is this hash of the root of the Merkle tree that corresponds to that single file. But additionally, we have something called piece layers, and this is again, it's like a dictionary in which the key is the root, the Merkle root, so piece root of the given file, and then the value is the hash of the corresponding piece at the piece layer, at the size of the piece. So in this example, you can see that if I scroll it over a little bit, so you see we have in this case 3 files. So you see I have one root here. It's very hard to see, but this is piece root for first file.
Yeah, I get it.
Then we have the second one, and then we have the third one. And then we have in this red color here, we have something that is called pieces layer, which is like in the middle of the forest in a way, or the layer of the piece size, to be able to validate even faster, basically. And what is also important in version 2, maybe nice to mention, is that in version 2, everything is aligned to the piece boundary. So that was important because also, as you mentioned, one of the objectives I think of version 2 was to be able to get to easily to confirm validity of a single file, basically. So the files always starts at the piece boundary, which is not the case in Torrent version 1, when they can start at any moment. Later they introduce extension again, they called padding files, through which they also in version 1 can align files to the piece boundary. And by doing this, actually they make two torrents or swarms compatible, because pieces are exactly at the same index, they start at the same offset, everything is the same, it's just how the protocol validates things is different. So let me go back to our...
I like all the illustrations you drew. They're really helpful.
To some extent, they help me. Actually, I think sometimes more than the others, but they are sometimes helpful for me to understand also the protocol and how things work. So now I mentioned that BitTorrent, after some time, they introduced DHTs. They didn't have DHTs at the beginning, they had trackers. So it was semi-centralized system in a way. But at some point, they introduced DHTs, which allowed them to create trackerless swarms, basically. So you didn't have to have a tracker anymore. You could ask DHT, get peers, given the info hash, and DHT was supposed to provide you with the peers that are advertising, announcing that info hash, that they have the content under that info hash. And that is important for our work.
What percent? Do you know what percentage of like torrent download performance is actually coming from looking for peers within the DHT versus just using trackers?
No, actually, I don't know. I don't know that how much DHT improved how it works, but the important thing is that the entry level is lower. Like if you want to serve content, you don't have to keep some tracker running. That's huge shift in how easy it is to use it, I think. Yeah. So we had that. Yeah. That was the DHT. And yeah, so to compare this quickly with Codex. So again, in BitTorrent we had this, we had pieces and blocks, and then in Codex we have just blocks, basically. This is the level we operate on. Default in Codex is 64 kilobytes. But as I said, our block size is flexible. And for the content that we want to store, the blob, the file, we create a Merkle tree. And the root of that Merkle tree is called tree CID. And similarly to BitTorrent, so if I, again, here we had the manifest, the torrent file. And in Codex, we also have a manifest, which is also a metadata file, which includes similar things in its basic version, at least, because we have, once we start talking about search providers and marketplace and more advanced features that Codex provides beyond what BitTorrent can do, then we have more sophisticated and comprehensive information in our manifest files. But basically, in altruistic mode, at the same abstraction level as BitTorrent, we also have content size. We specify block size, not piece length like in Torrent, but block size, which, as I said, default is 64 kilobytes. And we specify tree CID, which is can be compared to InfoHash, basically. Well, not exactly as we saw in this previous picture when I mentioned that, okay, in version 2, when they introduce Merkle trees, then every file has its own Merkle tree. So the content is kind of a forest of Merkle trees, and InfoHash designates that whole forest. In our case, we have tree CID, which designates the basically blob, a sequence of bytes, sequence of blocks, and we announce that tree CID on our DHT. And similarly, as they had then InfoHash to kind of allow you to designate the info dictionary, in our case, manifest CID content identifier. I didn't introduce that. We should maybe sometimes mention that very important improvement in our protocol is the use of content identifiers, which allows you to uniquely identify content on the content addressable network.
I drew this a long time ago, like 2 years ago. I'll throw an image of it on the StreamYard. I think there might be some more fields I'm missing. Maybe some things might be out of order, but this was all kind of the metadata that was associated with a CID in the context of Codex, right? So,
yeah. Now in the version, we have also still CID version, codec encoding. Indeed, so this is also multi-codec basically, and then indeed when you start adding storage providers and marketplace support, you start doing erasure coding, which creates more data, adds parity blocks basically. So yes, we add more and more to that. When I was here, so if we now compare a little bit how we work in Codex with data. So again, when you join a swarm, you have your content identifier of the metadata file. So in Torrent, you had InfoHash. In our case, you start with metadata CID, content identifier. And you can also exchange that CID out of band. You don't have to really use DHT to discover peers having manifests. If you have your manifest, you can send it to someone else and someone can find the tree CID out of it and kind of use that. But normally you ask DHT for peers that potentially keep the manifest CID. You get the peers, you discover, you connect to those peers, you're trying to fetch the manifest. Once you get the manifest, in the manifest, as I mentioned just a moment ago here, in the manifest we have tree CID, which is then something that identifies our blocks, basically, blocks that belong to the given content. And sorry, too far. And then you get the peers that also announce under that tree CID, and you start doing downloading of blocks basically. So you address. So in case of BitTorrent, when you normally were in the protocol level, you request pieces. So you say, I need piece for that info hash with the index. In Codex, you asking for give me the block under tree CID with that index, and then you're getting blocks basically. So you see, it is actually, if you look, lots of things are similar. Yeah, the details are of course very important, and the differences make both protocols incompatible. Of course, and BitTorrent uses different protocol than we do, and things are slightly different, but some concepts we can see are similar. So now when we want to bring those two things together. So we have this is Codex, and this is BitTorrent. So DHT here and DHT here, and how we can somehow build BitTorrent support on top of Codex. So in our case, we announce manifest CID and tree CID, and in case of BitTorrent, we announce info hash. So why not to announce info hash additionally on our DHT and get some extra information that allow us to connect those things together. So this is what we do in bringing together Codex and BitTorrent. And maybe before, like, so I will start with this, but I have a slightly more detailed description of how this really works. But the important thing now in our DHT, we announced 3 things: info hash, tree CID, and manifest CID. So let's look quickly how does it work. So when you are content seeder, you have your file. The first thing that you create is a regular Codex manifest, exactly as you would do in Codex. And having that Codex manifest, you announce manifest CID and tree CID, so that the content can be discovered as a regular Codex content. But once you have this manifest, and you have, in particular, when you have Codex manifest CID, and you know what kind of what blocks you have, you know the content, you are seeder, so you can create info dictionary, which will be standard info dictionary as you know it from BitTorrent. But then you connect those two, so we create like a manifest file for BitTorrent in which we include info dictionary, and additionally we include a CID of the Codex manifest. So by this, we are saying those 2 things are connected. This content which can be found on Codex belongs to that info dictionary. So under that info hash, you should get that content. And we announce BitTorrent info hash to our DHT. And now when you want to get it back from Codex network, we have, again, some API in which your input is, again, info hash, because, of course, we do trackerless torrents, and the only really information is content identifier, which has to be BitTorrent native identifier. And so it's info hash. That's how BitTorrent identifies content in the end. So we create content identifier from that info hash. We ask our DHT, okay, give me the peers that are saying that they are having content related to that info hash. So we get the peers, and from those peers we can get the BitTorrent manifest, in which we will find the info dictionary and the CID of the Codex manifest. Now when we have Codex manifest, we can ask our DHT, give me the peers that are holding this manifest. Once we have those peers, we can get Codex manifest. Inside of Codex manifest, we find tree CID, which, again, regular Codex business. We get we ask DHT again, give me the peers that are having content under that tree CID. We get the peers, and by normal protocol exchange, then we are getting blocks. And this is exactly what was described here. So first, get peers for info hash. From that we have torrent manifest. Then get peers for manifest CID. We get peers for manifest CID, and then we get manifest CID from them. And in the end, in the third step, get peers for tree CID and index. Actually, that would be even get peers for tree CID only. The index at this stage probably is not even included. And we start getting blocks for that tree CID and index from those peers. And it's not the end of the story, though. So we are getting content, but if you are looking carefully at this, if I jump back here, we have info and Codex manifest CID. So now if I am a malicious node on the network, well, I can send you BitTorrent manifest under that info hash with Codex manifest CID pointing to something completely different. than actually original info hash was referring to. So you expect get picture of your lovely cat, but you get something else. So how we fix that in a way? And we do. So we have a two-level validation, how we can do that. So I mentioned that Codex uses content identifiers, but the content identifier that we create for the info hash, it's not like really valid content identifier because it describes it describes torrent manifest with one extra attribute. So we cannot really validate the requester downloader doesn't know if this Codex manifest CID really belongs to the right content. So at the level of downloader, from his perspective, he doesn't know yet what will be the Codex manifest CID. He only knows the info hash, and that's the only input. So, okay, but having Codex manifest CID, so when we fetch, when we get torrent manifest, in the inside of the torrent manifest, we know there's an info dictionary. We can encode that info dictionary, hash it, and by this, we can compare the info hash that downloader has while requesting content with the info hash generated or created from the info dictionary from the torrent manifest file that we just got from our Codex network. And if they're equal, then we know, at least at this stage, that the info hash and info dictionary are matching. So the info hash in the torrent manifest is actually truly the info hash the info dictionary corresponding to info hash that we are requesting. But then for Codex manifest CID, we need to do second stage validation. So having Codex manifest CID, you remember we are doing regular Codex business. So we start getting blocks, basically. We are getting blocks from Codex network. And we know that pieces in BitTorrent will be bigger than individual blocks. So usually when you only get the whole piece complete after you get a number of blocks. So you aggregate those blocks, you get one after another. As I also show here in the picture for piece 0, you have a number of blocks. And at some point you have the piece. You fetched a number of blocks for the piece. Once you have the piece, you are hashing that piece. And now you again comparing that piece with the corresponding entry in the pieces attribute in the info dictionary. And when you compare those two, you can see, well, they match. So we know that that piece, at least that piece that we just got, that we aggregated blocks for, is matching the content that info dictionary describes. So this way, we guarantee that what the user gets is actually what the user is looking for. So it's like two-phase validation process. Yeah. Are you with me still, Jessie?
Then I can make... Yeah, can you hear me?
Yes, yes.
Yeah. No, so I understand what's going on here. You're doing...
You got frozen.
The hash of the B-encoded info dictionary. Oh, you can still hear me though, right?
Yes, now yes. Yeah.
Okay. Yeah. So yeah, I see what you're doing in terms of trying to do a two-stage validation. You do the hash of the B-encoded info dictionary to get the info hash, and then you verify that the info hash is the same as within the torrent manifest, and then you're going to take the Codex manifest CID and then start downloading different blocks, generate pieces, hash the piece, make sure that the hash of that piece is within that piece attributes field. Yeah. So it's a two-stage validation. Yeah. So that so if you send me a duck with a torrent manifest file and I download it, the image should be the same as what you said versus a swap out. Yeah.
Yeah, and again, we can have a very short demonstration on how this feels like when you actually try to use that API. So hopefully I can switch my screen. If I do present, how can I present?
I can help you switch it. Yeah.
Okay, so I will I will do stop screen for the moment at present, and will share now my whole screen. That's this one. And
there you go.
Yeah, so I have 3 terminals. I hope, is it possible to somehow see the text on them?
There's like a solo layout here.
Oh, yeah, sorry. Yeah.
Is that better? You could probably do. Is that even?
Is better? Can you read the text a bit from terminals? Sorry,
it's legible. Yeah.
Okay. We don't have to read the details. There will be some important bits and pieces there. So actually, if you would go now, I'm sharing screen, so I can switch between windows. So if you go to our documentation, sorry, if you go to documentation, then you will find out this is the published documentation. I can also go to my vault, but let's stick to this one first. So there will be this page. I see in search you just type implementing, and there's this implementing Codex BitTorrent extension, which documents how this thing is realized in Codex in the code. These things are still, this is living documentation. So when I'm updating or refactoring code, those things are changing. But at the end, we have this small steps for upload and download BitTorrent content with Codex demo. So how you can run 2 nodes locally. So it's not like a real field test, but allows you to see how those abstraction and how everything that I explained to you will normally work. So you see that there are a few steps. You have to start 2 nodes. We start with node 1 like this. So this will be in our first terminal. We will generate some content that we want to announce. We will upload that content to that running node, from which we will get the info hash. This is actually multi-hash, but if you go below after the multi-hash is only identifier of the hash. This is SHA version 1, so it's 1114, and after that is actually real info hash of the B-encoded info dictionary. Then we start node 2. Well, there's sometimes when you run things on local host, sometimes those nodes somehow do not see each other, so you have to like connect them, make sure they are connected. So that steps to make sure that the nodes are connected. And then we try to stream that content from node 2, which will run in another writer terminal, and we should get that content back. And this is exactly what I will try to do. So I have those 2 nodes already running. I am in my test data folder, and at least there's a number of files here ready. I tried with different size of contents. My favorite for the moment for this demo is data 10 megabytes, but I have to make sure that we get a fresh content so that the nodes still do not know it, because that changes how they stream it. Yeah? If the node already had that content fetched before, then it will be in something we call local store, and it will just give it from the drive. And we want, in this case, something more sophisticated. We want the nodes actually to contact each other, and that downloader actually gets the data from uploader. So I will now delete that data 10 megabytes file. For the moment, I will shift the terminal to the middle of the screen. It will be slightly easier. See, we don't have that file anymore. And then I will do, I will generate the same file name with now random different content. So we get 10 megabytes of content with the same file name. We have it here again. And now I will be uploading that file. So make a gap here so we see the uploading going on. And to upload, I just use standard curl post request, in which I specify the content. This is our API entry point, v1 torrent, and specify what file I want to upload. So when I do this, oh wait, well, we you should have seen something more here. Oh yeah, wait, sorry about that. I apparently didn't scroll properly. I hit some. If I do it again, then you see, yeah, I had the terminal scrolled basically, so you didn't see it flowing. But now you see, the content is uploaded, and in the logs you see that it created the BitTorrent manifest, and it prints that BitTorrent manifest. There are a number of things in it. You recognize the info dictionary. There's the length of the content, the piece length, which in this demo I'm using 256 kilobytes, and then you have pieces, and you see a number of pieces for that content. There will be a number of them, and what this thing returns to us here in the terminal, we see again, this is this info hash that I mentioned, right? So having that in this info hash, I can now try to fetch that content from the downloader node on the right. So I will make some first housekeeping here. So I will do, it's so ugly sometimes. Okay. I will store our info hash that we just got back from the uploader in info hash variable. We have that here. And now I can request that content from the second node. So actually, to just make sure that maybe it's visible, you see here, I'm contacting node on localhost on the port 8001. That was this one. Now I will be asking for content from localhost 8002, which is this one. This is, if I would scroll it far enough, you would see that this is exactly the node that I'm running. So it has API port 8002. So this is really this node. So we are downloading it from different nodes than uploading. So now I will do here a couple of, now let's hope it will nicely be visible. This is wrong command still. We want to use info hash. We just recorded info hash. Yeah, this is the command we want to use. So 8002 Codex version 1 torrent info hash network stream, and we will record that file under info hash.bin name. So now if we, why when I hit this think it doesn't work very well. So now we probably see the problem that I mentioned, that they are maybe not connected, although they should be, in my opinion. It's nice to have some demo effect, so we see how in practice it behaves. So I have a command to get the peer ID of that other node. I should have echo. Should see that. Then I should be able to connect them. Oh, that was this one, I think. Yeah, we can connect those two nodes together. So now they are connected. I think this hit and enter here is not a good idea. It destroys some kind of terminal behavior. It actually did stream something, as you see. We just didn't see that. Yeah, I didn't expect that somehow. When I tried this before, I didn't do that, and now I did, for thinking it would be more readable, but it wasn't. So actually, now let's very quickly, because it doesn't cost much energy. Let's do this. I will remove that file quickly again. Now you know the steps, so it actually will be more fluent and easy to observe. I generate the content again. I will upload that content, which we will see things now. I will not hit that enter anymore on the terminal. So
yeah, I hate when you hit enter in terminals in different shells. Like it interrupts the log reporting so that it doesn't automatically roll properly. Yeah.
Yeah. So now we get it again. We got new info hash, and I will store that info hash under export variable. So we get the same. And now I will be getting that content again. So 8002, and now whoop, and we see it's going, yeah? And we see we got it. We can also very quickly in that terminal, before I will explain something from the log, we can do this kind of thing. We can see the hash of the original content, and we can then compare this. That was, if you remember, that was the info hash that we, under which the content is identified, and we fetched that and downloaded it under that file with extension bin. So if we compare those hashes, they are identical. And now the nice thing, why I was insisting on doing actually on first uploading fresh content to uploader, and then downloaded this fresh content from downloader, because you see this interesting nice effect in the log. You see a sequence. You see a repeated pattern. There's always something like waiting for piece to be ready. This is important. So Streamer, the application that sends the blocks to us, basically, it cannot send you the blocks immediately as it gets them, because as you remember in BitTorrent version 1, you can only validate piece at the piece level. So before you aggregate all the blocks and validate that piece is valid, you should not deliver blocks to the customer because they may be fake. So this is the Streamer waiting for the piece to be ready. Then we have a message from background downloader, which is downloading the piece. It got the piece, all the blocks, validated it. And then the Streamer said, oh, I got the piece, and now I'm streaming blocks. And you see the streaming blocks, and there's block index, and you see those indexes going. And for every piece, you get the same. So you see that actually Streamer is always faster. Yeah, the fact that the aggregating blocks and validating comes in the background. So it's important to synchronize those two. Otherwise, we would be delivering maybe garbage to the customer. And then one more last thing that I want to show about it. What is super nice. You remember that Torrent manifest includes includes Codex manifest CID, right? So this thing is, and this is, as I said, regular Codex business. So this content is actually stored as regular Codex content. So if I can now fetch.
So I should be able to pull it from you on my Codex node if you're,
Yeah, so I can show you some interesting. So I will now first do what I first will do. I will first get the manifest of that info hash that we just fetched. So you see we got it here, and now you can see actually that manifest, the Torrent manifest, and you see Torrent manifest is info dictionary length, piece length, and then we have those pieces, and at the end we have Codex manifest CID. So, so this is nice. So I can copy that Codex manifest CID, and what I can do now, so instead of using Torrent API, I can use regular Codex data API. And instead of using info hash, I can just put here this manifest CID, and I will do as a second, and I should get that content from Codex. So now if I do this again, and if I do that would be the info hash. So this is the content. So this is how we store that with -2. So you see that they match again. So this is kind of nice, because at the moment you have the content available, which you can refer to as regular Codex blob, basically, or Torrent file, basically, which is in a way interesting, intriguing, and powerful. I think it's a nice feature.
That's really awesome work, Marcin.
Yeah,
that's awesome. So now I can take all my anime and I can download it with this into the Codex network, and then I can push it into our testnet cluster.
yeah. Well, you mean if you add if you now will be doing regular like this extra Codex feature like using a marketplace to have storage provider that will pay for that will guarantee storage. Then you can see that we are quickly going beyond just BitTorrent. We're starting not to be in best effort protocol like BitTorrent is, but we starting having warranties without doing anything. It's like we just slightly build a thin layer on top of Codex, and we can take lots of fruits and advantages from
So
it.
how do you see this integrating with like potentially the Codex Vault app that Arno and Akil build?
Yeah. So now, so actually, I will reshare now my other screen in which I have like some closing notes about what we're going to do with it. So as I mentioned, this is early thing. Yeah, it's not really field tested and deeply, but it's production code. So it's kind of ready to start being tested. But before but as I said, our current experiment is the paving the way for something maybe bigger. So of course we would like to have BitTorrent version 1 fully supported with files and dictionaries. That would be nice. But and BitTorrent version 2 has long hanging fruit. Not sure if in this order that I'm presenting that here, but we would like to have that. But more importantly, experimenting with a BitTorrent guides us to something bigger. So first, okay, in BitTorrent you can only download the whole data set. Yeah, right. If you publish folder, you just get folder. That's it. And we would like to see if we can provide like selective files download, so you can have a data set and then you can indicate which file from the data set on which subfolder of the data set you are interested in.
Yeah, that would be awesome.
And this should bring us to last 2 points on that list, to files and dictionaries supporting Codex, basically. So going beyond BitTorrent, and we look at different solutions that are out there, PeerKeep, for instance, Arclone, and seeing how those things can interact with external world, how actually users of Codex could be using that functionality, how they can take advantage of files and dictionaries supporting Codex. And on top of that, what would it mean for a storage network to have mutability in place? So you are not like, imagine you have some sort of like a regular experience people have with things like iCloud or something when they can, and when things are in the network, and just at the moment when they need them, they just point out, I want that, and it goes back to your drive, and then you change that and it goes again. And imagine it's decentralized on the back end with all these warranties that we have through marketplace and storage providers. I would be super great, because that would mean if we have that working, we are really player competing with all storage providers from the cloud on centralized services. We would be able to do something that before was hard or not possible to do, basically, to make sure that the centralized backend, let's say, is as reliable as centralized backend, let's say. And that would be super awesome. And again, our experiment involves now integrating with either or both BitTorrent client. It could be transmission of BitTorrent. Maybe who knows? We are not at the moment thinking of interfering with commercial BitTorrent client, but with this open source clients, probably one of those will be our target, to see if we can integrate that, so you can smoothly you get the content, or you seed the content and you seed it. You know that it's available on BitTorrent, and you automatically, for instance, seed it to Codex. So now people that use Codex with BitTorrent extension can actually get it without even using BitTorrent client. So that would be one thing. The other thing, what you exactly mentioned, we have Codex app, for which we are ready. This is the easiest path for us to integrate this kind of things, because at the moment we operate on through REST API, basically. So it's low hanging fruit again to integrate those extensions with Codex app. So we will certainly think about it.
Cool. Awesome. I'm gonna pull down the presentation and then just put us here again. Cool.
Yes.
Well, thanks again, Marcin. I don't know if is there any other kind of last minute things you want to go over or share?
No, I think actually we reached the end. The links and the documentation we can publish it under the video for reference later. So we shown most of the things we shown. We have the docs. We try to use Obsidian Vault for like also as a part of experiment to see how easy and flexible is to create searchable documentation using Obsidian Vault, which by the way also nicely integrates nowadays with HackMD and this kind of solution. So you can actually have community editing work together on some content, and then when it's more ready and more stable, put it on Obsidian, publish it. Very, very stable technology. So we cover that. We cover how BitTorrent works, maybe with some inconsistencies here and there, but more or less picture should be correct. And we've shown how we do integrate BitTorrent with Codex with a thin layer extension of top of Codex and advantages coming from that. And we also wrap up with what's next. So I think we are kind of done.
Awesome. Cool. Well, thanks again, Marcin, and thanks everybody for watching. Excited to share more.
Thanks for this opportunity to be here. Nice.
I'll on from the team and then just share whatever everybody's working on, because like all of it's really cool. We just it's kind of hard to like break away and find some time to just chit chat about like what everybody's working on. So like I'm glad.
Yeah, I think it's nice for the format of this that this is not really like screenplay kind of thing, because then if you can go without preparation or something, and if you would have to prepare, then it will be harder to find time to do that. So I like the format in the way that okay, we can talk through it, and kind of I think it's great doing this way.
Cool. If you know any other, like any other pieces of information or any other work that we should probably
there will be coming certainly more. I mean, now I'm studying quite deeply all those backup solutions, like really per keep and things, and see how they organize blobs, how they use metadata in blobs. So there will be things that will be influencing probably how we go in. What are we going to do with that, basically? Because as I said, when looking at the files and dictionaries, we really want to figure out what should be the minimum set of features that our protocol actually have to support to enable this kind of next layer solutions. And that's very exciting. Lots of things to learn, lots of things to learn, but it's interesting. So there will be coming more and more stuff. Good also that that Dimitri is also looking into that stuff, and he's feeding me with some like directions where to search for stuff. So it helps me somehow to. He's done some level of filtering already, and it's nice to kind of already have some directions. I'm trying to dive into this a little bit and have my perspective on that. So, and hopefully it will be.
Do you have any use cases that are top of mind that you want to see this integrated with first and foremost, beyond the Codex app and anything else?
Well, if I would, I mean, the thing that I mentioned, something that all those things like per keep and our clone and something try to achieve. So they try to do something like backupping and synchronization of your data. It's a powerful thing. I would like to have that. Like I remember when Keybase was introduced. And now it's taken by Zoom, But before it was really trendy in our group. I would say we have lots of people around using Keybase, and it was super convenient to like have that feeling that you drop it there and you don't have to think about it anymore. So it was centralized system. So imagine we have the same decentralized. And the problem with Keybase is that it's centralized. So when it's taken by Zoom or someone, people have concerns. So I would like to see something with the same level of security, in a way, have this kind of decentralized drive with encryption and with some reliability guarantees and durability that we want to have. And for Codex, that would be probably the most important, the first thing that I would like to see myself, I think.
Awesome. Well,
so you could go away from iClouds and this kind of things. That would be great to have something like that.
I know that the EthOS folks, the guys who are doing DGen 1, the kind of like, it's not necessarily an Ethereum phone, but something akin to that. I know there's a lot of people who are looking for some way of synchronizing their files, whether it be on desktop environment, mobile environment. So yeah, I'd be definitely.
So you remember before I joined IFT, I was playing with my thing called Identity Box, and later it transformed to something that I called Homebox, and I wanted to think of it like like every household has some sort of like a box that you place inside, almost like in the Dutch households, everyone has something that they call meterkast, which is the place where these electricity meters are and things. Imagine you have like a fixed spot that when you enter home, you just put yourself into it, and then you become, and your home becomes like a node in the network immediately. And not only node in the network, so because it becomes node in the network, you get access to this decentralized storage, like something like almost like constitutional right. You have access to storage, you participate, you co-create that network, and additionally, this thing kind of bootstrap like local home infrastructure, and maybe on top of that some identity platform if we need it. But this is also changing in my mind. Maybe we want something different than identity. To be more privacy preserving, actually, but having this kind of digital like digital you, basically, like you plug yourself and you are, if you remove that box from your home, you are off, you are not there. It's kind of nice. It could be that your data are still there, but you are off, and then if you have this kind of thing, you can think of making some kind of nice bridges between like local things. I was myself thinking about like energy management systems, maybe intelligent charging, this kind of things that you can do inside your home in a way better way that it's done right now. When everything, like people, when they charge their cars, for instance, they have those wall boxes, or they use some kind of brokers to provide access to charging schedules and controlling charging of their cars. And this is really like very badly made, because they give their credentials to some broker, and it hops through a number of steps sometimes. So they really kind of sacrifice privacy and security of their own car in a way, in the name of convenience. And I would like that they actually keep as much as possible offline, and then what is online is safe and decentralized. That like two words coming together, like offline and an online that's safe. That would be kind of nice.
I like the most recent person who I discussed this with is like Pol from DAppNode. So like that they have like the little NUCs where you basically can run a variety of different nodes across.
No, wait, I lost you for a moment.
Many different infrastructure, like some kind of hybrid between like Urbit, DAppNode, what Greg from Akash wants in terms of like some sort of like intelligence for the home, where you can plug it in and it manages everything locally, and then also if you need cloud storage, then it can potentially host that data as well. Like I think there's going to be like some sort of convergence of a lot of these different ideas that everybody has, because at the end of the day, nobody wants their data to be like their private data. They don't want it to go beyond the walls of their home or wherever they're.
So interesting things is that we all struggle with this problem that most of the people still very often do not care that much about decentralization, for instance. But when I was searching for like doing customer interviews and things, when I got to some meetings of energy management communities, then the users themselves, they reportedly were bringing two issues. The first was that they would prefer that their infrastructure is more offline. so that they don't depend on
Yeah.
internet connection to control electricity and everything else in their home. And the second,
Yeah.
if they are connected, they were concerned with being dependent on single provider, through which there were cases reported in the Netherlands, for instance, that some people couldn't access their home basically because Amazon or something suspended the account, for instance, something. So those people actually start observing those concerns faster than for instance in messaging frameworks. Like if I ask people about their privacy behaviors in with messaging, I was almost not non-existing there. And a surprise for me a little bit, the younger generation seem to be more ignorant than the older, and that's was strange to me, because I used to think it would be other way around. But when I met people like in the 40s, 50s, they had stories very often about setting up their own email server, setting up their own storage node and something. And so they were concerned. And when I asked like people around 20s, they were very ignorant. Like they just grab first thing convenient, basically, and they didn't even notice when they were using WhatsApp that WhatsApp is saying that something is entered and encrypted. They didn't even notice that, and didn't matter to them very often. So interesting. And so it's a challenging thing. That's why I said we need to have something that operates as good as those kind of iClouds and things.
I think everybody knows that it's the problem of, like you're saying, the new generation, they're making hidden trade-offs that they're not really aware that they're making in terms of compromising their data, whether they're not, for instance, flicking the little toggle in WhatsApp in terms of
I think very often the consciousness is that some of those people say that some of them are already convicted. Not convicted, but convinced that that everything is anyway already.
It's already out there.
Yeah, it's That's pointless to resist. Let's say.
It's like a. It's like it's not embraced nihilism. It's like embraced apathy, I guess. Something like that, like
and surprisingly, actually, there's one application area that I am very surprised that nothing exists there, that I know at least. There's hell of like accounting softwares which are centralized. But imagine that it's actually impossible to find any single one which is end-to-end encrypted.
Oh, interesting.
It's like tons of people are using those accounting systems. And those data is actually, well, even if it's encrypted, it's not end-to-end encrypted, and often it's not even encrypted on the backend. So it's only traffic is encrypted often, and lots of people, lots of business owners are, they don't have choice. So probably that's why they feel comfortable with it in a way. But funny.
There's this one open source accounting software. I was trying to pull it up. I remember speaking with them a while back. I don't personally use it, but Rotkey. Rotkey was the accounting software.
Rocky.
But ROTKI. Rotkey. I can put a link. I'll probably put a link in the chat.
Yeah. Rotkey. Or on Discord.
Yeah, put it in both. Here you go. Put it in the private chat here, and then I'll put it in Discord.
Cool. Yeah.
There you go. So you might be right in terms of the backend not being encrypted, but no, not Peter. Lefterist Carpetsas. Yeah, him. He would be probably interested in something like this future down the road, because I think by end of the first half, I know that Dimitri plans on adding encryption as part of the
I
mainnet,
also
right?
saw Giuliano reporting issue related to that. And for instance, if we will speak about the Keybase, they had this great feature on command line that you can on the spot create a shared folder. That was it is both a great usability feature, but also like it's actually challenging encryption scheme that they have to maintain to make it happen. I like that a lot. When you could just have shared folder on the spot.
I know that they were trying to, anyway, we'll talk about it in another podcast, but we'll wrap up. Thanks everybody for tuning in. Hopefully this gets edited pretty fast and goes out to everybody, but thanks again, Marcin, once again, and we'll talk more soon.
Thanks. Hey, see you.